Following on from the previous video, we were trying to obtain the reduction formula. So we started out by saying, let this be this, and then it was blah blah blah, and then we got to this stage here, and then here you've got one block multiplying cos squared. We'll break this cos squared up into cos times cos. So now because this is the exact derivative of this thing here, then this thing here is easy to integrate. So break this up into this and into this. Because this is easy to integrate, we're going to use integration by parts. So let's just concentrate on this bit. Ignore this negative. So we are going to try and integrate this. So that will then later give us something, and then later we're going to put this something back into here. So let's just concentrate on this bit. Ignore the negative. So looking at this bit only. So looking at that, let's try and integrate that only. So let's try and integrate this. So this thing, because this is the exact derivative of this, we should set this to be our u prime. So u prime is this thing here. Okay, so if u prime equals this, so we are now using integration by parts. If u prime equals this, if you integrate this, it will give you this. Because if I were to give you, let's say, integrate sine to the power 6 x cos x, that's this cos x here. If you were to try to integrate this, you would look for something in such a way that when you differentiate it, it gives you this. Well, imagine this sine to the power 6 as being this. Hang on. Sine x to the power 6. Let's imagine it as this. So because this is the exact derivative of this, make this to be your, so for you to integrate this, you're looking for something in such a way that when you differentiate it, it gives you this. So make this to be your initial guess. Sine to the power 7 x. So now if you differentiate this, it will give you 7 sine to the power 6 x, and then you've got to times it with the derivative of the bubble itself, So that would be cos. You see, this cos here matches up neatly with this cos here. So now you don't want this 7, so negate the 7. So you see, integrating this is easy. It's basically this. So when you integrate this, it just gives you this thing here. Well, anyway, let v be cos. If v equals cos, then v prime equals minus sine of x. So now it's saying, the formula is saying get u times v. So get u times v. So that will then give us this. And then you've got your minus, and then you've got your minus here. Then you've got your minus here, and then it's saying get u times v prime. Get u times v prime. But because you've got this minus here, then this minus here will then turn into a positive. Well, basically it's saying get u times v prime. Get u times v prime. That will then give us this. Okay. Well, think about it. It will then take you to here, and then let me think. Well, and then what? Hang on. Oh yeah, and then here you've got 1 over n plus 1. So take this out. That will then give us this, and then what? Let me think. Oh yeah, and then let's oh yeah. So now we've just integrated this, and then it equals this. So going back here, we were trying to work out this. Going back here, we were trying to work out this, and then we got to this stage here. We've now just worked out the integral of this, so we can put it back into here. So hang on, let's start again. Let's start again. So remember, we've just integrated by using integration by parts. This thing here equals this. Okay, so let's start again. So we are trying to integrate this. So we would blah blah blah, and then we got to this stage here, and then we've just worked out this bit here. This bit here is us using integration by parts. we've just worked out this bit here. This bit here is this thing here, and then so now we can put this thing here. We can put this thing here into here. So that would then give us minus this, and then well, I've not explained this very well. Hang on. So we've got this. Put it into here, and then because of this minus here, it's going to be a minus block here. That's this block here, and then you've got a minus here, and then so it's going to be this, and then minus this. So this will then be a minus this block. I've not explained this very well, so you just got to live with it. Okay, so now that will then take us to here, and then if you look at this here, this is the same as this. So this block here is actually f sub n. So this is your fraction here, and then this is your f sub n. So now you've got this thing here. So now add this block to both sides. We're trying to merge these two together. So add this block to both sides. So that will then give us this. Okay, and then now this is in common with this. So let's merge them together. So this will be 1, and then you've got your fraction. So basically, if you get this times this, that will then give you this. And then let me think. So this thing here will then become this. So that will then take you to here, because you want to get this on its own. So times everything by the reciprocal of this. So that will then, so this thing here would then become this, and then this thing here would then become this. So what it means here is that if you're trying to work out, let's say sine to the power of 8 of x, then it's saying work out sine to the power of 6. Work out and then times this n minus 1 blah blah, and then you've got this thing here. Well then you if you're trying to integrate this, you need to know sine to the power of 6. You need to know this. Well, how do you find sine to the power of 6? Then you would set this to be 6. So you've got to work out sine to the power of 6, and then that will be blah blah, and then sine to the power of 4. Then plus this thing here, and then how do you work out sine to the power of 4? So you would set this to 4. So sine to the power of 4 would be you working out sine 4 take away 2 sine squared. And then once you've got your sine squared, you can work out to the power of 4. Once you've got to the power of 4, you can work out to the power of 6. Once you've got to the power of 6, you can work out to the power of 8. So that's the idea behind it. I will illustrate it with an example in the next video. Okay.